Let's analyze the thermal growth. Here, we have a straight pipe between a pump and a pressure vessel. When the pipe heats up, it tries to expand, but the fixed connections at both ends restrict this movement. Significant thermal stresses develop in the pipe and equipment, which can lead to pipe or equipment damage, support failures, or leakage at the joints. So, how do we manage this expansion? Let's explore some solutions. First, expansion joints. Expansion joints are specialized components designed to absorb thermal movement. They're particularly useful when space is limited, and installing a large loop is not feasible. In this example, we've added an expansion joint between the pump and the vessel. When the pipe expands, the joint compresses or flexes to absorb the thermal growth. However, there are a few things to consider. Expansion joints require regular maintenance. They can add cost to the project, and proper anchoring and guiding of the pipe are critical to prevent issues like squirming or joint failure. Next, we introduce an expansion loop. This is a simple and effective way to manage thermal expansion. By adding a loop into the piping system, we create flexibility. When the pipe expands, the loop allows it to bend and absorb the thermal growth. This greatly reduces the stresses on the pipe and the connected equipment. Expansion loops are common in long, straight runs of piping and are cost-effective because they don't require special components. However, they do require extra space and can increase the overall piping length. Notice how the stress is reduced compared to the straight pipe scenario. This is a simple and effective solution. Another effective solution is rerouting the pipe to create natural flexibility. Here, instead of using a straight connection or adding components, we adjust the route of the piping to accommodate thermal movement. By changing the layout, we allow the pipe to flex naturally when it expands, without significant stress buildup. This method is often cost-effective and works well in smaller systems or when space permits route optimization. However, rerouting may increase the piping length and require additional supports. To summarize, let's compare the 4 scenarios. 1. Straight pipe, high thermal stresses with no flexibility. 2. Expansion loop, provides flexibility but requires space. 3. Expansion joint, compact solution but requires maintenance. 4. Pipe route change, uses natural flexibility but may increase piping length. Each solution has its pros and cons, and the choice depends on factors like space availability, cost, and maintenance requirements. Always remember, proper design for thermal expansion is essential to ensure the safety and longevity of piping systems. Thermal expansion may seem like a small issue, but if not addressed properly, it can cause serious problems.